Okay, I'm going to do these videos in two parts, so you can just use specifically which video you need. Okay. Firstly, let me just explain the basic process. Okay. So if we have a vector, specifically one that goes, I don't know, just making something up here, totally, 240 newtons at 25 degrees, and the one that comes up 140 newtons at 70 degrees. The idea here is that we need to be able to get to this final vector. Okay, now we've been doing that specifically with graphing. What we're going to do now is what's known as the component method. So I'm going to go over the basic gist of how the component method works to begin with. I'm going to go over a little bit of trig here to begin with, and then I'm going to do another video specifically that does all the stuff specifically for this particular problem right here. Okay, so if you remember with normal addition, okay, if I just come up here and I go make a number line, okay, 0, 1, 2, 3, 4, 5, 6. All right. If I have say +2, +3, you know, that is that is just two vectors going in the same direction. You go from the end of the first one and then keep going. And then your answer is a vector that goes from the beginning to the end, known as a sum or a resultant. So technically, normal addition is vector addition. It just made a lot easier because there's only two directions. So we call one positive, one negative, and we can kind of memorize the results, right? In 2 dimensions, that becomes a lot harder because there's a lot more possible options, sort of. Now, when we first started doing vectors, I asked how many possible directions there were, and some people said infinite, which is correct, but also some people said 4, which is also correct. Meaning, essentially, we have one number line up here in a straight path. It just kind of runs along the x. Okay. Here, we just have 2 number lines. We have one that goes along the x and one that goes along the y. So ideally, what we could do is we could just do this twice. Figure out how far it goes on the x, figure out how far it goes along the y, and we're good. So how are we going to do that? Well, let's imagine that, I don't know, you had a vector that looked like this. Let's call it C. Okay? And I made 2 vectors, specifically one along the x and one along the y. We'll call that one A and that one B. A and B are equal to C. They mean the same thing. C would have to be written like we normally do. It would have to be written something like, I don't know, 10 newtons at an angle of 30 degrees, right? That would be one. But if I had a vector for A and a vector for B ending in the exact same spot, 10 newtons at 30 degrees is technically equal to A plus B. You know what? Let's not call those A and B. Let's instead call this one, I don't know, X, and this one Y. So 10 newtons at 30 degrees is equal to whatever that X is plus whatever that Y is. I just need to figure out specifically what they are. So how do I get X? Well, here I have the magnitude of the vector and the angle, so I can just use trig, right? This is the adjacent, that's the hypotenuse. So cosine of 30 degrees is equal to adjacent x over hypotenuse 10 newtons. Do a little bit of algebra, and x is equal to 10 newtons times the cosine of 30 degrees. And then I can do the same thing for the y. The sine of 30 degrees is equal to the opposite, y, over the hypotenuse 10. Once again, just multiply that up there. So y equals 10 newtons times the sine of 30 degrees. But I don't even need to get that level of specific. If instead of saying 10 newtons, I just call this some value of r, who knows what r is, then this equation, I'm going to ignore this guy right up here. This equation just says that the x is equal to whatever's on the r times the cosine of whatever the heck angle that is. And this will give me the value for x. One of the main reasons why that works is because the cosine, which, as we've said before, gives the adjacent over the hypotenuse, is kind of like a percentage. Meaning, like, let's say this cosine ended up as 0.174. Technically, that's compared to 1. What that says is 100%, if 100% is r, then 17.4% of that is going to go on to the x-axis. So in this way, I can use trig to figure out how much of this vector here travels along the x and how much travels along the y. And I can do the same thing here for y. Instead of 10 newtons, let's just say r. And instead of sine 30, we'll say sine of whatever the heck angle that is. This would give me, this generic set of equations right here, would give me the possibility of knowing any r, knowing its angle, and being able to calculate what x and y are. Now let's say instead I had a triangle in which we only had x and y, and we wanted to know r. So in the first one, we knew r and theta, we were trying to get x and y. What if we had x and y and we were trying to get r? Meaning like, hey, we have 3 here, we have 4 here. Well, how do we get that that's 5? Well, that's just Pythagorean theorem. A squared plus b squared equals c squared. So x squared plus y squared, that's your a and your b, is equal to c squared. Now I'm going to shortcut to the final answer and just square root that side right there. This would allow me to get from x and y to my value of r. And let's say I just had x and y, and I didn't have r yet, and I wanted to get theta. Well, opposite, adjacent. So the tangent of the angle is equal to y over x. And as you've probably started doing in your homework, we could take the inverse tangent of both sides to get the angle. So these two equations allow us to go from r and theta to x and y. And these two equations allow us to go from x and y back to r and theta if necessary. All right, I'm now going to proceed to the second video with these equations in mind and answer this particular problem.